Hi, my name is Jessie Hoagland, and my best practices are math manipulatives for primary and secondary grades, both physical and virtual. So what is it? A physical math manipulative could be any kind of small object, something to write on, something to draw on, any kind of tangible thing that the student can hold or use to really see the math problem in front of them. So if you're doing a subtraction problem, they can really see the numbers and what they are doing in front of them. And since it's so hands-on, it just really reaches out to the students and gives them a better understanding rather than listening to the teacher give a lesson or completing a worksheet by themselves. A virtual math manipulative are usually very similar to the physical math manipulatives. The only difference really is that these are located via any kind of technology device, so you could find them on your iPad, computer, and there's plenty of websites that I listed below where you can access these, and they're really like based off of the physical math manipulatives. So if you can find something that's a physical math manipulative, you can usually find it in the virtual form as well. And these are really good for students who may not have the manipulatives in their home. So when they go home to do homework, they can look these up online or at the library computer, and they can still do their homework and understand it. And it's good for teachers who may not have a certain kind of math manipulative in their classroom, so they could look them up on the projector. And then what does it look like? Physical math manipulatives could come in any form, such as an erase board, a number line, dice, measuring tools, counters, just so many things, way more than are listed right here. And many that are used in primary classrooms can also be used in secondary classrooms. It really just depends on the purpose. So an example of this would be the geometric solids shown right here. These could be used in a primary classroom to teach the students different shapes. However, if it was used in a secondary classroom, it would be used to teach the students about surface area, volume, and other topics around that. There's all of these different physical math manipulatives right here, and I'm just going to walk you through them really quick. The place value blocks are also known as base 10 blocks, and students can pick them apart or put them together, and the bigger ones right here, those are called flats, and they are made up of 100 cubes. The ones right here that are longer are made up of 10 cubes and are called rods, and the ones right here are single cubes and they are ones. So you can use these when completing a math problem, and it makes it really easy for the student to see what's going on. Snap cubes are similar to the place value blocks, and you can just snap them together, and they come in a lot of colors, and it's just like a great way for students to see what's going on with the math problem. Pattern blocks show students how shapes can be broken down into different shapes, and they also are great for showing volume of an object or area. The teaching clock can be used by students to help them learn how to tell time and tell the difference between the minute and the hour hand. As a teacher, you could have your student set the clock to a specific time, or you yourself set the clock to a time and have them read it. The small foam dice, they don't have to be foam, really any type of dice in general can be used as a math manipulative in the classroom. They can be used in many different ways, such as for maybe a primary class, you could have a student roll the dice, and if it's a 2, ask them what it comes after 2. Or have them roll it again, and then whatever number comes up, ask them, well, what comes 4 after this number? And there's just so many variations you can use of that. In a secondary classroom, if you have students completing long equations, you could have them roll as many dice as you want, and then plug in the numbers from the dice so that everyone gets a randomized equation to complete. And we already discussed the geometric solids. The fraction bars are great because fractions can be a very difficult topic for many students to learn, and it just shows how all the different fractions can fit into one whole. And it just goes down, and it's just really great to show there's 2 halves, 3 quarters, and they all go into just one. Virtual math manipulatives look like these right here, and there's many more than this. Most of them are based off the physical, as we discussed earlier. As you can see in this clock one right here, it's very similar to the physical clock manipulative. It just has a couple more options on the bottom to where it can be customized. And they can come in many different shapes and forms, but you can only access them through technology such as an iPad or a computer. And they can also overlap as well, as discussed for the physical math manipulatives. This right here, where you can have the lines and you can connect to make shapes, is great for showing the area of an object and showing that an object does take up space. And then these right here are the base 10 blocks as discussed earlier, but just in a virtual form. And you can see how the student used these blocks to complete this problem right here. These triangles, I thought they were pretty similar to the pattern blocks because it shows how different shapes make up other shapes, but it can also describe area. Since math manipulatives largely vary in their use, there's not really a set procedure on how to use them. Like a clock manipulative would not be chosen to be used in the same lesson as a geometric figure. And so there cannot be a set procedure to be used with all of the manipulatives just because they are all so different. It really just depends on your lesson and the student you're working with and what their specific need is. So if you're using the base 10 blocks in subtraction, I just did a very specific example to show a procedure and using them. And I thought that it was great that I have this image right here to show you this exact problem, 134 minus 121. And it has the student using the base 10 blocks, the 100s, the rods, and the single digits right here to show the place value and then do the subtraction to see where the difference comes, which gets them to 13. The online graphing calculator, I found this online and I thought this would be very useful in many classrooms because most students have to buy an online graphing calculator at some point in their education career, and these can be very expensive. And you can pretty much do anything you can do on a graphing calculator on this one, and I put that link below if you're interested in that resource. But you can just type in an equation right here and it'll pop up over here, and then the computer will graph it for you, and you can put more than one equation over here and graph multiple things at the same time. And I thought this would be great if you're trying to show students the difference between the opened and the parabolas that open up and the difference between those that open down. So they could type in different equations and see how those are graphed and start to realize the similarities and differences between those equations. Modifications to support students with disabilities. Math manipulatives can be used for really any student at all, and they're especially great for students who may struggle in math or students that may have a disability because it really just makes the whole lesson so much more hands-on and just very visual for them to participate in and see what is going on. And students with learning problems often let the process of actually computing a math problem interfere with their ability to understand the problem-solving aspect. So if a student is trying to solve a very long equation, they may be stuck on one small part of it rather than looking at how to actually problem solve. And in this case, it might be good to allow your student to use a calculator. Many teachers believe that using a calculator will inhibit the student's ability to compute math on their own, and that is not true. I think that it should only be used in certain cases and certain lessons. I would not let my student rely on this, but for some students this may be a really useful thing to use, such as the online graphing calculator or even a handheld one. Fractions have been considered one of the most difficult concepts for anyone in general to learn, and with a learning disability this can make it seem even more impossible. We talked about the fraction bar up here, and I thought that would be a great resource to use with students who may struggle with that, and because it just gives them so much detail on what's going on inside of a fraction. And then understanding the place value of a number is also a difficult topic for students, and we discussed the place value blocks or the base 10 blocks and how those could be used to explain to students the difference in place value, such as the hundreds place and the ones place, and it really just lays it out in front of them so they can see what is going on with these numbers and the difference between all of these places. Time can also be a difficult topic for students to learn, and we saw the two different manipulatives for time. There was the physical clock and the virtual clock, and just having this in their hands with the numbers so much bigger and the hands on the clock so much bigger, this could help a student understand telling time better. And then I found some information in the book on how a teacher should teach time, and it had students sequence the events in their day, and even if their routine at home is not very similar every day, the routine at school would be pretty similar from day to day or week to week. So having students think about the sequence or schedule of their day and which events take longer and which ones are shorter can help them understand the concept of time when they're starting to learn how to use a clock. And really, math manipulatives are just great to use with anyone. I've seen them a lot in my clinicals, and I've seen the students really be successful in their math problems through using them. And it gives them a great way to check their work as well. Since they can see everything that's going on, they can also check their work right in front of them. I have some resources right here at the bottom, and I have the National Library of Virtual Manipulatives. This is a great source to see all kinds of different virtual manipulatives that you may want to use in your classroom. Here is upper elementary, middle school, and elementary. And then here's the link to the online graphing calculator, which could be useful. And I also used the book on finding some information. You can find some on page 383 through 387. And my questions for you now are: number 1, do you prefer physical or virtual math manipulatives and why? 2, if you could only have one math manipulative in your classroom, what would it be and why? And it could really be a manipulative that's not featured on here because there's just so many that I really could not put them all on here. And then number 3, as a student with a learning disability, how can math manipulatives influence your achievement in a math classroom and why? All right, guys, thank you for your time.